Hello, hi. I'm back before you. So the experiment is starch hydrolysis under see you see these this sort of miniature windmills closer miniature windmills. I actually made this as a part of Mahatma Gandhi spinning loop. I may have shown it over the days on my YouTube webpage, but and then solar power. Well, at this time of the year in Toronto, solar power is it? But it's a sunny day, and if I were to calculate, from the internet data, 1 watt per meter square, but it gives rise to zero point 0.1 plus or minus a degree centigrade. And the room temperature at this time, thermostat says 20 degrees centigrade. Although the heated thermostat is set at 75-degree Fahrenheit. The turbine, I've run the fan, and the this came. This was glue. The glue came off. Oh, how would I set this? Maybe just place it on. Place it on. Place it. Place it on this. Let's see. I'll be calculating. We'll see. I'll get the, if there's a little bit of wind velocity coming. The sun is shining. Wind velocity coming. Then, cornmeal, 25 grams, starch hydrolysis, I said, right? So cornmeal, 25 grams of cornmeal. My beaker is here. And 1 teaspoon. My beaker is here. Zero this. It's just maybe just 25 grams. 25 grams. So I could have added cornstarch, but I have worked with cornmeal back in my U of T days. So just see. So just cornmeal. Yeah, 25 grams. Because each gradation is 25 grams. Let's set this aside now. Put this back later. Cornmeal. So 50 milligrams of and we'll zero this. Yeah, zero. 50 ml of water. There's anyway, starch there in my 50 ml of water and a teaspoon of amylase. So this is 100 ml. I'll add 100 ml of water. 100 ml of water. And an enzyme. So we'll stir this first. So there's a cornmeal with And I can use a regular spoon. So I'm going to use a regular teaspoon. So 1 teaspoon of alpha amylase. And then for further use, so we'll set the timer and let the, this is, okay, maybe the fan is enough. I just want to see this turn once, just because I made it. The fan is enough, I think. It's turning. So I'm going to set the timer. This miniature windmill doesn't work because, oh, it's turning. It's turning. Can you see? It's turning. So maybe closer to this. The sun. Maybe set the timer. Start turning round and round. So this is just some velocity. So maybe increase the fan speed. Getting cold. Oh, you need a lot of wind. You see, you never think about these things. It's turning this way. Start turning round and round. It's going to fall off. It's going to fall off. So fan, I'm going to reduce. I'm going to go closer to the fan. Setting one. And we'll move it here. Setting one. And temperature. So 0. So 25 grams for cornmeal, 100 ml of water, 1 teaspoon of enzyme, 0 and 0, 3, 6, 9, 12, 15. So that's the fan speed. Well, that I decided the windmill effect, but it turned. Isn't it interesting? It did turn round and round though, because yeah. So I turned like a paddle. Yeah. I have a sweater on because I started turning the fan on, right? So what's the so this is the right time. So so 1 teaspoon. $12.5. I'm going to put it back so the reactant. So you'll have to consider the density of mixture, and then balance the equation, and then so starch to glucose plus starch plus water, glucose plus oxygen, is it? Well, maybe oxygen, and then that will lead you to the right density of the mixture, and then you'd have to take the amount you've taken, the mass of you've taken, of course, then density, and the volume is so concentration. I'm going to be doing a slight change. Residence time distribution for discrete data. This is discrete data, right? Not continuous measurements. So I'm going to be doing so. I like this experiment because it's not toxic. Yeah, well, it's just food engineering is the best. But I thought I would do fancy things with iodine colorimetric and everything, but that never worked. That didn't work. So my miniature windmill works, except it doesn't go round and round. But it broke. It broke. I had glued it. It broke. Yeah. So that side of it. My 1 more minute, and I take my next measurement. So you can see a little bit. I move this. Yeah, there's my weighing scale. Stir, stir. I've considered mixing speed, mixing velocity, and how much energy. Newton's laws comes in. The third law. Every equal action has an equal and opposite reaction. So it actually cools. The opposite reaction cools the fluid. So when you're stirring, some heat is generated, right? I mean, is it friction? There's no friction, but kinetic energy. Kinetic energy. So it should make it hotter, but it cools the liquid. Yeah. So 9 minutes. Okay. Look at what the lump is. This is dropping. One third. 25/3. Stir, stir, stir. So it's mixing at a micro level. Micro mixing is happening. So that with Ms. and Mims and Civil, I'll show you the portion where they've looked at the discrete data and from pulse input tracer analysis. So this would be the portion I would be looking at, and variance, etc. With just my measurements, you don't need sets of data, etc. So that kind of makes it nice and good. My total reaction time is 15 minutes. So this is 6 minutes. 9. I've taken 9. So is the watch going slower? Yeah, and so what's the lump? Lump is glucose. Lump could be a problem, in a reactor. A big lump could see there's a big lump here. That could be glucose. Or glucose is happy. Glucose is getting me. But big lump could be a problem in a reactor because the impeller could get messed up. The functionality of the impeller could get mixed up. And even in lab reactors, turbine. Almost there. Yeah. 6 minutes. Let's drop to 25/4. So I should have gone closer to this. But as I'm feeling the fan speed. Velocity. Changes the pressure, right? The pressure of the air. So reaction happens faster. That tastes maybe a little too much. So there could be 100% conversion. The first point I had 50% conversion, or 12.5 grams per 100 meter, 100 mil. So solar power, but didn't kind of work out together. Solar power, but that's just 0.1 degree centigrade. So it's good, but if it's too windy, it's difficult to harness. But the right kind of wind, it's the right energy to harness. You can convert it to electricity, and with the wind turbine. Just take this. Two. Indonesia. Solar power. But it doesn't heat very well. In places like Bangalore, where there's sunlight most of the time, but there are also cloudy days. I mean, rains and sometimes clouds the day, rain clouds the day. So my in-laws had a solar heater, which they thankfully changed to electric heaters, and they're both dead now. But and we haven't gone and stayed there in years. But in some years, last was 2015. Oh, years, 10 years, right? So it's been 10 years, 11 years. So they the solar it will not heat which used to be sort of lukewarm water. It's okay in Bangalore, but I like my showers. So to make this, last point, and then I show you my measurements and sign up. All right. So lots of mixing. So this is like CSTR. There's no inlet and outlet, but discrete measurements, inlet and outlet. I'm not gonna check. I've not been on the go. Last set, they say. So Professor Molly Shikett, the associate chair, is checking. So she, I've been on the go since yesterday. We used my telescope, giant sunset telescope, and it's found the Newton's rings, concentric rings. Yesterday was also sunny in Toronto, really sunny, and the concentric rings, and that led to some uh, uncovering of recent data. And then another experiment this morning, and but I think 4 p.m. is the deadline, or 5 p.m. They keep changing it on me, you know. 25 by 2. Okay. So those were my measurements, and yeah, those were my measurements. 25 grams of cornmeal, 100 ml of water, 1 teaspoon of enzyme, and time points. I'm a little more organized, but I had a hitch with the miniature windmills falling apart. Anyways, I will sign out. All right, thank you. You're watching me on my YouTube webpage.